Bismillah ar-Rahman ar-Rahim, my dear students of Ajman University, College of Pharmacy. Today we're gonna talk about the second topic في disperse systems. We already talked about suspensions and today we will talk about emulsions. Remember that suspensions and emulsions belong to coarse dispersions. Okay, there are types of coarse dispersions. Okay, if you remember, in suspension, we said that the internal phase, or let's say the thing that is distributed throughout the outer phase, the inside phase, we call it dispersed phase, if you remember, and for suspension, we call it suspensoid. Okay. Now, the dispersed phase في emulsions is frequently referred to as the internal phase or the discontinuous phase. Okay, so in comparison to suspension, the dispersed phase is usually referred to as suspensoid, but in emulsion is usually referred to as the internal phase, okay, or the discontinuous phase. For the dispersion medium, or the other term dispersing phase, in emulsion we usually refer to it as external. See, opposing to internal phase, we have external phase, and opposing to discontinuous phase, we have the continuous phase. Okay, so this is what we call the dispersion medium. Okay, so if I want to draw for you an emulsion, okay, with globules inside, circles, spheres inside, okay, these globules, okay, will be referred to as the internal phase, and the outer things, the surrounding these globules, اللي هو الاكسترنال أو الكونتينيوس phase. Okay, now in emulsion there are three important constituents, okay, or the composition of emulsion consists of three main elements. First is an aqueous phase, okay, another phase which is oily, and of course you know that if you try to mix water and oil, okay, what you're gonna find, you will find that the water and oil will separate. Okay, in order to bring them together you will need the third component اللي هو we call it emulsifying agent. We call it emulsifying agent. Okay, طيب, what are the types of emulsion? Is the aqueous phase is the external phase or the internal phase? Okay, what about the oily phase? Well, actually it depends on the type of emulsion. We have three types, or let's say we have mainly two types, and then we have a special type. Okay, so what are the types? We have oil in water. We have oil in water emulsion. This is one type. What does it mean, oil in water? If I say oil in water, it means the internal phase is oil and the external phase is water. Okay, but when I say water in oil, it means the internal phase, the globules high, they are aqueous, okay, and the external phase is the oil. Okay, طيب, isn't these are the two main types, and we have special type of emulsion that is referred to as micro emulsion. Micro emulsion, we will talk about it separately later. Now, for what, or these emulsions, what do you use it for? Well, there are emulsions that are used for oral administration. Okay, so we have oral administration, and we have also emulsion that are applied topically, for example, on the skin, and we have even emulsion that are applied parenterally through IV. Okay, and we might talk a little bit about this later. Now, uh, some emulsions are in semi-solid form because most emulsions are liquid, but also we have many emulsions in the semi-solid form, and we call them creams. Is an emulsions in the semi-solid form, we call them creams, and they are usually applied topically. Okay. طيب. Now, there are certain preparations, some of them you have already encountered, like lotions, liniments, cream, and ointments, and some commercial vitamin drops. Now, some of these preparations are in the form of emulsion. That's why emulsion includes certain lotions. طبعا, when I say lotions, it doesn't mean that all lotion preparations are emulsion. No, some of them are suspension, some of them are solutions, so some of them are emulsion. Okay. Okay, now we will talk about why emulsion. Why emulsion? See, this preparation here that we talked about is not a stable preparation. يعني thermodynamically it's not stable. Eventually, if you leave it for long enough time, eventually it's gonna separate and maybe it will go to this state. Okay. So why are you going to prepare an emulsion that is thermodynamically not stable? طيب, one of the reason is palatability, or to make it, or permits the drug that may be in an oily state. Okay, it's an oil, you cannot drink it because it doesn't taste well. So what you do, you take this oil and put it in water. So you have an emulsion where the oil is in the internal phase and the water, flavored water, may be in the external phase, and this will allow you to taste, or to be able to consume or take or administer the preparation without having to taste the bad tasting oil. Okay, so palatability, or to make it palatable, to make the drug in oil state, to make it palatable. طيب, another thing, if you look here, you will see that these globules are usually small. For example, half micrometer or 1 micrometer. It means I am converting the preparation, the drug, into small globules. And because of that, because I'm reducing the size, it will be more readily absorbed from the GIT. Not only that, but even for preparations such as mineral oil, okay, which is taken for as a laxative or cathartic preparation, even for preparation like mineral oil, it is more effective as a laxative, okay, compared to administering mineral oil not as emulsion, just as an oil. Okay, so making mineral oil or liquid paraffin, this is the other name for mineral oil, making it in the form of emulsion is not only improving the taste but also making it more effective, okay, as a laxative. So there is another reason, is an palatability, better absorption, more effective, and another thing, it's less irritating. If you have a medication that is, when applied to the skin, it irritates the skin, okay, if you have such medication, then you can make it in the internal phase. You can make it as globules in an external phase that will dominate the spreading on the skin. Okay, and it will make the medication less irritant because it will not have a lot of direct contact with the skin. Okay, and it's kept in the internal phase. Okay, so it will make medication less irritating. Another reason is when we look at the water in oil emulsion, we will find that the spreading of such emulsion on the skin is even, okay, and uh, the oil will spread easily on the skin because the skin has sebum. Sebum are the secretion from the skin, okay, from the follicles, hair follicles, that will allow your skin to be oily. And if you are applying water in oil emulsion, because oil is in the external phase, it will spread evenly. And the good thing, it will soften the skin. إذا وجود الأويل as external phase, it will soften the skin and it will resist the drying in the skin. Okay? Why? Because you have the skin and above it you have a layer of oil which prevent the water from escaping the skin. But the problem is that washing it, if you want to remove it, then it will be difficult to wash it with water. So in the case you need the preparation to be removed easily from the skin, then you will need an oil in water emulsion. It will be preferred in such cases. Now, another reason why we do emulsion, they found that emulsion will enhance percutaneous absorption. And you should remember transdermal drug delivery system because there is percutaneous absorption. Now, they found that emulsion, because of reducing the particle size, okay, it will enhance, okay, the absorption of some drugs into the systemic circulation, and we have such preparation that I will talk about later. Now, theories of emulsification. How will you be able to allow oil and water to mix with each other, forming an emulsion? This is something strange. So we need to know what are the theories behind that. طبعا there are three theories, and to be honest, usually in any emulsion you will find the three working together or in synchrony with each other. Okay, yes, maybe for example one of them is dominating, but there is also the effect of other factors or other theories is involved or involved in the formation of emulsion. طيب, what are these three theories? One is the surface tension. Okay, two is called oriented wedge theory. Three is plastic or interfacial film. Okay, I'm gonna talk about it easily and quickly. First of all, you need to know that for any liquid or any two liquids that are immiscible with each other, there is what we call surface tension or interfacial tension. Yani, let's take this cup. Okay, let's assume there is only water. Here there is surface tension. What does it mean? It means that the water molecules are attracting each other inside, and also the air molecules are attracting each other here. And because they are attracting each other in this way, they are forming a tension here, and this will not allow the two to get inside each other. There is a kind of repulsion. Okay, طيب, this one we call it surface tension. Isn't with air, it's surface tension. But when we have two liquids that are not miscible with each other, what you have here is referred to as interfacial tension. Okay, now again, This surface tension or interfacial tension will not allow the two liquid to get inside each other. Okay, that is because of the attraction forces inside each one and the repulsion between the unlike molecules. Okay, طيب, when you have a water tab, okay, and you have here the tab, okay, you are closing it, and there is a drop of water coming down. It will come down in the form of spheres, right? Okay, now why they are spherical? Have you ever thought of that? The reason why they are spherical, it's because spheres have the lowest surface area to volume. Okay, for this volume here of water, what is the lowest surface area? It's this one when it's in the spherical shape. طيب, why water drops and many other drops they take the spherical shape, and why do they want to make the lowest surface area? The reason is the surface tension. The surface tension is preventing these drops from forming in different shapes. They are taking the form of spheres. They are trying to expose the lowest surface area so that the tension is not very high. Okay. طيب, why I'm talking about these things? Because I want to explain to you that tension is not allowing oil and water to mix with each other. And one of the things that can work اللي هي by adding a surfactant. And what does it do exactly? You see here the figure. It is surrounding the globules, the internal phase. You will see that there is like a tail here and a head here, and depending on the tail and the head, which one is hydrophobic, which one is hydrophilic, you will have the globule, whether this globule is an oil, okay, or it's a water. For example, surface active agent, why do they call it surface active agent? Because they go to the surface. For example, if it is in this shape, you will find them here, and you will find them also here. Okay, they like to go to the surface or to the interfacial area. Okay, so when you have an emulsion, they like to come and surround the globules, the internal phase, and by that they will protect these globules and they will reduce the surface tension. Isn't what is the job of the surfactant? The main job of the surfactant is to reduce the surface tension. And if you are able to reduce the surface tension, one material can go inside the other material. Okay, but how you gonna stabilize it? This surfactant will surround the internal phase or the globules, and it will protect it from coming to other globules and uniting with them. So they will be happy, they will stay there for as long as possible. Okay, isn't let me just repeat it quickly. The surface tension theory says if you reduce the surface tension between the two liquids, يعني you are influencing the attraction of each molecule with each other, okay, and the repulsion between unlike molecules, you are trying to influence that. You are trying to reduce repulsion and also reduce the attraction of one globule to another one. Okay, that's the job of the surfactant, and this is very important, and this is one of the main way by which globules can be formed as internal phase. Okay, now the question, what type of emulsion it will produce? It says it depends on the surfactant. If the surfactant is more hydrophilic يعني loving water, then it will cause oil in water emulsion. If the surfactant likes oil more, then it will cause or will produce water in oil emulsion. So oil will be in the external phase if the surfactant or surface active agent likes oil more. طبعا we'll talk about this more later. طيب, the other way is referred to as oriented wedge theory, as you see here, and usually it's through a polymer. Okay, you have a polymer, and this polymer stabilize the internal phase through what? Through this wedge. Okay, so it is forming monomolecular layer around the globule to protect it, and the wedge is inside the medium or the external phase, so that it's like holding and protecting the internal globules. In pharmacy, most of these preparation and the important ones are oil in water emulsion. Isn't most of preparations that are working through oriented wedge theory will produce oil in water emulsion, and they are the important one in pharmacy. طيب, the third way اللي هي referred to as plastic or interfacial film. Here we have some solid particles. Okay, they are very fine solid particles, and they surround the globules and protecting it and stabilizing it. Okay, so you have protection here from the globules going and forming or coalescing with another globules. Okay, how it's protected? It's protected through what we call this plastic film or plastic interfacial film. Okay, so they will not coalesce with each other. Okay, because remember, if you have coalescing between the globules, then you will start to have separation between the two phases. Okay, I hope this is clear. طيب, what type of emulsion you will produce? طبعا yes, it depends on the solid particles, if it loves water more or oil more. But another factor which is very important here اللي هي what is the proportion of oil. Usually if the oil proportion is high, then it will be water in oil emulsion. But if the proportion of water is more, okay, then you will have oil in water emulsion if the water is more. Okay, so it depends mainly it depends على proportion of the external phase and the internal phase. Okay, the higher one will be the external one. إذن with surfactant I can get water in oil or oil in water depending on surfactant. This is the surface tension theory. With oriented wedge, most of them are or the most important ones, and most of them will produce oil in water emulsion, because most these polymers are water soluble. Okay, most of them are water soluble, and they are the important ones in pharmacy. For solid particles, mainly it depends on what I said, on the proportion of oil and water in the emulsion. طيب, as I said, usually it's not a single theory that is able to explain everything. Now we will talk about emulsifying agents, because these are making wonders. These are responsible for making emulsion to be not stable. It's not a stable preparation, but almost stable for a long period of time. Okay, because eventually it will not hold indefinitely. طيب, such as what? We have carbohydrate materials. Okay, examples, and you need to memorize these examples. We have acacia, we have tragacanth, we have agars, we have chondrus, we have pectin. These are carbohydrates. Okay, and usually these materials will produce oil in water emulsion because they love water. It's very well known that acacia is frequently used in the lab and in the extemporaneous preparation of emulsion. So they usually use acacia. And they use tragacanth and agar usually as a thickening agent. Okay, يعني to increase viscosity. Okay, if you remember in suspension, if you want to prevent the suspensoid from settling down quickly, then you need a thickening agent. Similar things happen here. If you don't want the internal globules to move and unite with each other, keep the medium little bit thick so that they don't move easily and unite with each other. So example of material, as I said, tragacanth and agar, and if you remember, we have also microcrystalline cellulose. Other materials, emulsifying agents include protein substances such as, or protein derivatives such as gelatin, egg yolk, casein. Casein is from, it's a major constituent of milk, and they produce oil in water emulsion. For gelatin, it has a disadvantage. The disadvantage in emulsion is fluid, يعني very liquidy, very fluid. Okay, and even it becomes more fluid when it's standing, and we need it to be little thick. Okay, other types of emulsifying agent include high molecular weight alcohols. Okay, and please, when I'm talking about these things, I want you to start looking at creams when you go to Carrefour or Lulu, etc., and you are looking at, or even pharmacies. When you look at creams, look at the constituents, because you will start to see these materials. Okay, I want you to be professional in this area. Okay, for high molecular weight alcohol, stearyl alcohol and cetyl alcohol and glyceryl monosterate, they are there, and you find these constituents a lot for creams. They are primarily as thickening. That's why they are, you find them in creams. They are thickening agent, and they are stabilizer for oil in water emulsion that are used externally. Okay. For cholesterol and cholesterol derivatives, these طبعا cholesterol derivatives, they are high molecular weight alcohol, and they are used externally in to promote and to form water in oil emulsion. Wetting agent, here we mean surfactants. Okay, surface active agents, and they are of three types: anionic, cationic, and non-ionic. Depending on the surfactant, and as I said before, whether it's more water soluble or more oily soluble, it will either form oil in water or water in oil emulsion. Examples of anionic surfactant or emulsifying agent اللي هي triethanolamine oleate and sulfonates. With sulfonates, example is sodium lauryl sulfate. This is very famous example. You may find it for shampoos, for example. Okay, this is an emulsifying agent. It's anionic. For cationic emulsifier, we have a very well-known compound that is used as preservative, اللي هو البنزيلكونيوم chloride. It's not only surfactant, cationic surfactant and emulsifier, but it's also a preservative and has bactericidal properties. أما non-ionic emulsifier, and these are widely used when you have oral preparation. Okay, you have the sorbitan esters, trade names known as spans. Okay, span 20, like that, and these are more like oily soluble. That's why they will usually produce water in oil emulsion. Okay, and we have the more water soluble non-ionic emulsifier, such as the polyoxyethylene derivatives known as trade names tweens. Okay, now these surfactants will not work at any pH. Okay, for example, the non-ionic surfactant, they are the better ones, and they work from the range of pH 3 to 10. 3 to 10. Okay, cationic surfactants. Okay, cationic, they, as I said, benzalkonium chloride, they work from pH 3 to 7. And anionic surfactant, they will work at more basic pH. Okay, طبعا the best, you will see that the best that is probably suitable for most preparation is the non-ionic surfactant. طيب another type of emulsifying agent اللي هو colloidal clays اللي هي finely divided solid particles, and examples اللي هو البنتونite, and we have also magnesium hydroxide and aluminium hydroxide. As I said, the relative volume of internal and external phases is important in determining the emulsion type. Okay, regardless of the emulsifying agent colloidal clay used. For example, bentonite can form oil in water and water in oil emulsion. Okay, let me talk a little bit about the HLB system, but first I will go to this table. Okay, this is the HLB. Now, for emulsifying agents, especially I'm talking about surfactants, for these surfactants, they assign them an HLB value. HLB refers to hydrophilic lipophilic balance. يعني they are looking at the structure of the surfactant or emulsifying agent, and they see how much it's lipophilic and how much polar groups the molecule has. Okay, the more it's hydrophilic, the larger is the HLB number. Okay, and the more it's lipophilic, يعني loving oil, the lower is the HLB number. Okay, again, the surfactants are assigned HLB number, hydrophilic lipophilic balance. They look at how much. طبعا again, let me just to explain something. All surfactants, why they go to the surface? The reason why they like to go to the surface, for example, between globules of internal phase and the external phase, or between the surface of a liquid and air, why do they like to go to the surface? The reason is that they like both phases. يعني they will like, for example, oil and water. That's why they go to the surface. Okay, but they might like water more than oil or oil more than water. Okay, if the surfactant is more lipophilic, يعني has less polarity, the HLB value will be low. And if the surfactant has more hydrophilic groups, then the HLB value goes up. طيب, usually for most materials, the HLB value will be between 1 and 20. Okay, for most surfactants, but we have as high as 40. For example, sodium lauryl sulfate has a large HLB value, so you might have a very large number. Okay, طيب, إذن what is the reason for this HLB? They wanted to give surfactants number to indicate whether it's more lipophilic or more hydrophilic. And because if the surfactant is more hydrophilic, then it will form what type of emulsion? It will form oil in water emulsion. And if it is more lipophilic, it will form water in oil emulsion. And this is what you will see here. Okay, emulsifier will form water in oil emulsion if the HLB value for the surfactant is from 3 to 6, and it will form oil in water emulsion if it is more hydrophilic with HLB value from 8 to 18. You will notice that there are other also classification, okay, and you need to memorize this table, okay. Okay, these are examples of surfactants or emulsifying agent with along with their HLB value. Okay. Type another thing which I want to talk about uh, is regarding the oil that you want to use, such as mineral oil. Okay, such as mineral oil. This is an example. Okay, the scientists were able to give oils, okay, to give them HLB number, HLB value, depending on whether this oil will be in the internal phase or external phase. Okay, for example, in this case, water in oil, it means the oil will be in the external phase. Here, oil in water, it means the oil will be in the internal phase. So they give the oil an HLB number, ليش, for what? Okay, whether it's for internal or external. Okay, for example, it's 4 when it's external, and when it's internal, it's 10.5. This is to allow you to choose the right surface active agent for preparing مثلا oil in water or water in oil emulsion. I'll give you an example. For example, let's say I want to use mineral oil, and I want, because mineral oil does not taste nice, I want to prepare oil in water. شفتوا what I did? I said I want to use mineral oil. This is laxative. I want to prepare emulsion, and I want it to be oil in water. I want water to be the external phase, and I want to put nice flavors and sweetening agent في الاكسترنال phase اللي هو الwater, and I want to keep the mineral oil inside as internal phase, discontinuous phase. Okay, طيب, in this case I need surfactant with HLB value 10.5. 10.5. Okay, if you try to see 10.5, you will see here methyl cellulose giving you 10.5. So this one will be good surfactant to use it with mineral oil as internal phase. You got it? But scientists also said that usually combination of surfactants will usually work better than single surfactant. Okay, but in this case, let's say you want to take one that is 8 and one that is 12, okay, and mix them together, then how will you get exactly 10.5? Okay, now I will show you an example where you'll be able to do such calculations. Okay, okay, did you get it? Izan, why they give numbers, HLB numbers, to oils? Because this will allow you to pick the right emulsifying agent that has the corresponding HLB value. Okay, again, the oils will be given an HLB value. That value will differ whether it's water in oil emulsion or oil in water emulsion. Okay, طبعا for oil in water emulsion the value will be higher. Okay, and don't forget that you can produce water in oil emulsion if the HLB value is for the surfactant from 3 to 6, and oil in water emulsion if the surfactant has a value, HLB value, from 8 to 18. Okay, for mineral oil, I'm here specific. Okay, mineral oil 3 to 6. No, don't just choose any 3 or 4 or 5 or 6. No, it has to be 4. It will give you the best emulsion. Type 8 to 18, but for mineral oil, no, it's the best thing is 10.5. You cannot just go and choose any random value. Okay, Type see this example and we will solve it together. HLB values are additives and often surfactants are blended. For example, they need 20 ml من HLB emulsifying agents بحيث so that the blend will give you an HLB of 9. يعني they don't want to come here, they don't see any 9, okay, there is no 9, but they will blend more than one to get 9, HLB 9. So what they did, they took one emulsifying agent that has an HLB value of 8 and another one that has an HLB value of 12. So they need to mix them together to get an HLB value of 9, and they need 20 ml of this mixture. So the blend will take a ratio of 3 to 1. How did they get it? I will show you, and I will show you how they did the calculation using very simple method called alligation method. Alligation method. Okay? Pay attention and we will solve it together. First, what HLB value we need? We need an HB value of 9. Okay? طيب. Second, طيب, I will put the 9, this is the required one. I'll put it in the middle, and then above it on the left I will put the two surfactant HLB value. The smaller one will be here 8 and the larger one will be here 12. So this is what I'm going to do. Okay, so 8, 12, 9, 9 in the middle. See, 9 must be in the middle. Okay, طيب, now I will see the difference. What is the difference between the 12 and 9? There is a difference of 3. Then what is the difference between 8 and 9? The difference is 1. Okay, now this means that you need 1 part from 12 and 3 parts from 8. Okay, this is very easy and simple. Of course, there is another way, scientific way to do this, okay, but I will go with the easy one. Okay, so what you need 1 part from 12 and 3 parts from the 8. طيب, how? Okay, see, the total parts are 4. 4 اللي هو 3 plus 1 4. This is the total. From the 8 you need 3 out of 4, and from the 12 you need ايش 1 out of 4. Okay, which means 0.75% will come from the 8, the emulsifier that has an HLB value of 8. Okay, and only 0.25 or 25% will come from the emulsifier with HLB value of 12. طيب, so I need 20 ml. How much do I take from the HLB 8? Okay, you do take 20, okay, and multiply it into 3 by 4, 3 by 4, or 75% or 0.75. Okay, and you will get 15 ml. Okay, طيب, this is from 8. Now what about from the one from 12? Okay, what about how much do I take from 12? Can you calculate with me? How much you need? 1 out of 4. 1 out of 4 will be from the 12. So this is 25% or 1 by 4 multiplied into 20. 1 by 4 or 0.25 or 25%, and you will get 5 ml. See, 5 ml plus 15 ml and you have 20 ml, and this 20 ml, when you mix them, you will get an HLB value for the mixture of 9. Okay, now we talked about how to do mixing HLB value when you don't have exact one, and I told you that generally it's better to have more than one emulsifying agent, a mixture of emulsifying agent. Now we will talk about how to prepare them, and we will focus on small scale. In small scale, you can use dry porcelain and mortar and pestle because you need to do a kind of agitation. You need energy in order to break the oil and put it inside the water, or the opposite, water and break it inside the oil. Or also in small scale, you might use a mechanical blender, like for example, hand homogenizer or bench type homogenizer. Okay, see this one is hand homogenizer. You put the preparation and then you press on it to come out from this nozzle. Okay, here you have a bench type homogenizer. Okay, and here you have industrial large scale. Okay, you have this large tank, and you have inside this an impeller, we call it, something to do rotation. Isn't you need some kind of agitation in order to break. Okay, you cannot just put the oil, water, and the emulsifying agent and then wait for the emulsion to happen by itself. You need to use an energy to do the breakup. Okay. طيب. طبعا I'm talking about oil in water or water in oil emulsion in general. Now, what are the methods in small scale extemporaneous preparation of emulsion? What do we have? We have three methods. One is referred to as the continental or dry gum method. احفظوهم, you have to memorize it. The other one is the English or wet gum method. And the third one is referred to as bottle or Forbes bottle method. Okay, they are very easy. Okay, is in three main methods: continental or dry gum method, English or wet gum method, and the Forbes bottle method. See, in all of them you have gum, and that is a reason you will see later that in most of them they are using acacia. And if you remember, acacia carbohydrates will produce oil in water emulsion. Remember this. Okay. طيب. Now the three methods rely first in preparing what we call a primary emulsion. Primary emulsion is not the final emulsion. Primary emulsion is the starting emulsion, we call it. Okay, and for starting emulsion, the ratio of oil to water, هذا oil to water to surfactant is 4 to 2 to 1. Okay, isn't in all actually three methods, usually the primary emulsion is first formed, and the ratio of oil to water to surfactant or emulsifying agent is 4 to 2 to 1. Okay. طيب, why they call it dry gum? Okay, it's called continental or dry gum. The reason is the gum, the acacia you usually used, اللي هو hydrocolloid solid, acacia, is mixed first with oil, not with water. That's why they call it dry. And the reason for the name dry is that the colloid, which is water soluble, is mixed first with, what happened to the pages? Okay, let's go back. Okay. طيب, because it's mixed first with oil, not with water. If it is with water, then it's wet gum method. Okay, so first it's mixed with oil, but of course it doesn't like oil. That's why you should not mix it for a long time. It should be rapid and short time. Okay, then you add all the water. طبعا I'm talking here, let's say mortar and pestle, and you are triturating now. Once you add the water, you have to do rapid trituration. It has to be rapid, okay? Until you start hearing what we call snapping sound, like that, okay? That sound when you are triturating indicates that the primary emulsion is formed, and this is something nice because after that you can ish add the additional amount of water slowly while triturating until all of the water is added and your oil in water emulsion is formed. Okay, remember here if you look at this one approximately 4 to 2 to 1, this is only primary emulsion. It's not the recipe. The recipe will contain more water usually than the oil, okay? But for the primary emulsion you will notice that the oil is more than water, okay? In the English or wet gum method, the ratio for primary emulsion is similar, 3 to 4 to 2 to 1. But as I said, first you add the water to the colloid solid, the acacia, and then you triturate. Here you don't have to do it short time. No, you triturate. Okay. Then you start adding oil in small quantities with rapid trituration until you see that the mixture is becoming thick and viscous. What does it mean when it becomes thick and viscous? It means that now they are inside each other. Okay? Then, after you have this thick and viscous preparation, you add the other water until you طبعا with rapid trituration until the emulsion is prepared. طيب, the third method is usually returned for a preparation containing volatile oils or non-viscous oil اللي هي very light. The problem here, you are using mortar and pestle, and for these oils, because they are very light, if you want to use mortar and pestle, it will cause splashing, okay, when you are triturating, because you have to put energy and do it fast, you might cause splashing of the contents. That's why you say, okay, I'm gonna use a bottle, and essentially you are using the same dry gum method اللي هي continental. You are doing the same thing, okay? But the only difference is ايش? One, you are using here a bottle, while in the normal one you are using mortar and pestle في dry gum method. Okay, here في المورtar and pestle, you with the pestle you are doing the agitation, but here with shaking the bottle, okay, you are doing the agitation. Okay, so it's essentially the same, but here you are trying to prevent the splash problem. Okay, we talked about the three main methods. Now there are some specific methods. The method that I will talk about here is a specific, and I will tell you why it's specific. It's called in situ soap method. In situ soap methods, and we will be able to produce two types of soaps. One is called calcium soap and the other one is soft soap. I'm gonna focus about calcium soap, which is water in oil emulsion. طبعا in situ means in the place, يعني it happens يعني you are not adding an emulsifying agent separately. No, it happens while you are mixing an oil with an aqueous solution. This mixing makes reaction and emulsifying agent is created. That's why they say in situ. In situ means in the place where I am doing the preparation, the emulsifying agent is created. طيب, now I will talk about calcium soaps. This can be prepared by using vegetable oil such as oleic acid and lime water. You remember lime water? It's calcium hydroxide solution. Do you remember this calcium hydroxide solution? USP. This is a saturated solution of calcium hydroxide. Okay, so you mix them equal volume of calcium hydroxide with the oil. You mix them with equal volume, and the emulsifying agent will form, and this emulsifying agent is the calcium salt of the free fatty acids اللي هو calcium oleate. The problem is if you use equal volume of uh, oil, okay, like for example olive oil, if you use equal volume of olive oil and calcium hydroxide, then there is a possibility that not all calcium hydroxide will react with the oil. That's why you might need to add either additional oil, or you might need to add oleic acid or a free fatty acid in order to react with the remainder of calcium hydroxide. Okay, so this is a self-emulsifying preparation. As I said, this is an water in oil emulsion. Okay, and because it's water in oil emulsion, it's ideal where occlusion, يعني I want to protect the skin, to exclude it from external environment. Okay, and I want to soften the skin. Okay, and maybe the skin is dry, I don't want the water to evaporate from the skin, so I may use it for dry skin. Okay, now we will talk about micro emulsion. If you remember, we said the types of emulsions. We said we have oil in water emulsion, and we have water in oil emulsion, oil in water and water in oil. Now, what is micro emulsions? Micro emulsions are very different. Okay, even though they contain oil and water, but they are different from the emulsions, other emulsions we are talking about, because they are very close, very close to solutions. How? Micro emulsions are thermodynamically stable, يعني it can be stable for very long time, unlike the normal emulsion. Optically transparent, and you can see through. Isotropic mixtures, it's like solution. Okay, يعني all everywhere in the solution will have uniform physical property. Okay, it's very similar to solution, but this is a biphasic oil in water or water in oil emulsion. Okay, it's biphasic, it contains water and oil. Why it is thermodynamically stable and optically transparent, etc.? The reason is, if you look at the internal phase, it's only 100 angstrom. 100 angstrom يعني equal to 10 nano meter. Okay, 10 nanometer. طيب 100 angstrom, طبعا the range is from 100 to 1000 angstrom. ال 1000 angstrom is equal to 100 nanometer. So you have the internal phase size ranging from 10 nanometer to 100 nanometer. This is very small. Okay, if you compare it to the normal emulsion that we are talking about, they are 0.5 micrometer, يعني 500 nanometer and above. Okay, you should be able to convert these units from angstrom to nanometer to micrometer. Okay, isn't what I mean to say that the internal phase is very small to the extent that they are very close to solutions, but they are not considered as such. How can we how can we have such emulsion? This is through carefully selecting some surfactant that are classified as solubilizing surfactants. Even though they don't solubilize the oil is not soluble, but because they make the microemulsion as if it is a solution, that's why they call it a solubilizing surfactants. Okay, and the nice thing here is that the microemulsions may form spontaneously. Okay, يعني without the need to do agitation, you just put the right surfactants and then you will get the micro emulsion. For oil and water micro emulsion, they found surfactants with a range from 15 to 18 to be suitable in this case, such as uh, tween 60 and tween 80 polyoxyethylene, if you remember. Okay. طيب, what is the advantages of micro emulsion? One, they found that it has more rapid and efficient oral absorption, يعني even better than the normal emulsion. They found it to enhance transdermal drug delivery. Also, there is a good application in the development of artificial red blood cells, okay, and also in targeting cancer cells through cytotoxic drugs. Cytotoxic يعني drugs that causes toxicity to the cancer cells. Okay, targeting cancer cells. Okay, now we will talk about the stability of emulsions, and we will focus on the physical stability. If you look at emulsion, okay, and let me draw here the emulsion for you. Okay, this is an emulsion where you have globules of the internal phase inside this external phase. طيب, what happens? The sign of instability can happen if you start to see that there is an aggregation of internal phase. There is an aggregation. They are coming close to each other. Okay, and they are forming very dense. See here, it's not dense as the one that is here. Actually, what you see here is a sign of instability. But the good thing about this is that if you shake the emulsion, you will get things back to what it was. So this one is kind of acceptable, even though it's not sightly. يعني doesn't look nice, but still there is a problem. Another problem happens if the globules, let's say the internal phase is oil, and suddenly you start to see these globules because they are oils and they are light, okay, they are going up, okay, while so it's a kind of aggregation, but they are starting like to separate, okay, but still in this case you can shake the bottle and you can get the emulsion back. But what we call this, we call it creaming. Okay, we call it creaming when you have one layer of concentrated phase, okay, and another layer which has a very small number of the internal phase. Okay, so you have a layer of concentrated phase and another layer of light phase, so it's like two layers. We call it creaming. We call this process creaming. Now, creaming and aggregation still is fine, okay, it's still acceptable even though it's not sightly. But the problem happens if these globules start coming to each other and uniting, and that is called coalescence. Is an if the internal phase globules unite with each other, it will cause coalescence. And if more globules start uniting like that, then you will have a partial or full separation. You will start to have two complete layers, maybe one with the internal phase that is only internal phase and the other one with little of maybe emulsion happening. Okay, and this is a problem. This is called coalescence and breaking. Breaking because you have a phase, a complete layer that resulted from internal phase coalescing with each other. Coalescing is just to talk about globules uniting with each other. Whether coalescence or separation, that's it. You have a problem, and you cannot just shake and get things back to what it was generally. This will not be possible, okay, and you will have to maybe reprocess it, add another emulsifying agent in order to try and get emulsion back to what it was. So it's not reversible. Is an aggregation and creaming, they are reversible, but coalescence and breaking is not reversible. Okay. طيب, in order to test before you put the product into the market, you need to do testing for the emulsion. So what do they usually do? طبعا, as you are aware, you should not place the emulsion in high temperature or low temperature, in extreme temperatures. You should not do that because they can affect the coalescence and aggregation and the surfactant and the emulsifying agent you are using. It will affect that. Okay, that's why before you put this emulsion into the market, you subject the emulsion to some extreme temperature to see whether they can withstand this kind of environment, okay, for 3 months. If they can withstand for 3 months, it means they are good to go to the market. Okay, so you try at 5 degrees Celsius and you try at 40 degrees Celsius. Okay, and you see for 3 months what's gonna happen. Okay, if I store the product for 3 months at 40, what will happen? Okay, if I take the product, a new fresh product, I store it at 5 degrees for 3 months, what will happen? If they don't separate, if they are still stable, then it means my product will be able to withstand the normal temperature اللي هو 20-25 degrees Celsius. Okay, they may use 50 degrees Celsius. This is a bit high, but it will be for a lesser time. Okay, shorter period of time. Another thing that can affect the stability other than the environment, whether it's hot or cold, another thing is light. Some emulsions may be affected by light, and in this case, if it is light sensitive emulsion, then it should be stored in light resistant containers. But some emulsions may be susceptible to oxidation. In this case, you need to add antioxidants, one, to put it in a tightly closed container. Another thing is the contamination by microorganisms such as mold, yields, and bacteria. And for this, you might use a very well-known preservatives such as the combination of methyl parabens and propyl parabens. Otherwise, you can use alcohol in the external phase with a percentage of 12 to 15% in oil in water emulsion as preservative. Last thing I will talk about is examples of emulsions. One official example, official يعني is available in pharmacopoeia or official books, اللي هو mineral oil. Remember, this is the liquid paraffin. Mineral oil emulsion. If you remember, we said that it will be more effective and palatable. يعني patients can take it. Okay, the taste will be okay. So this kind of emulsion is oil and water emulsion. See, I'm using acacia. Acacia will always give you an oil and water emulsion. See, mineral oil 500, acacia 125, syrup 100, vanilla 40, alcohol 60, purified water to make up to 1000 ml. طيب, the way they prepare it is by drum gum method. Dry gum method اللي هو الكونتيننتال method. First they will start by preparing ايش؟ by preparing the primary emulsion. They will take all of the oil, this is 500, and they will take the emulsifying agent first. Oil and emulsifying agent. You will notice that the oil is 4 times the emulsifying agent. Okay, so they will mix them together, and after that they will need to add water. How much? 250 ml, because if you are taking 500 ml, then for the water it has to be 250 ml, and for the acacia it will be 125. So they will add water according to the dry gum method. They will triturate well, and then they will add the syrups, and they will add the vanilla to the alcohol, and then they will add this also, and then they will make it up to 1000 ml with water. Okay, طبعا this is cathartic, it's a laxative, and it can be used, or it has to be administered an hour before bedtime. For adult, the dose is 30 ml. This 30 ml will contain 15 ml of liquid paraffin or mineral oil. Okay, another laxative is castor oil emulsion. Castor oil emulsion, this is a laxative. It's given occasionally in case they want to prepare for radiographic or endoscopic examination of the colon. Okay, the castor oil might be administered. You have to be careful, because using laxatives for longer duration of time will cause dependence for bowel movement. يعني it will cause constipation in the future, and your bowel will not move unless you start taking castor oil as a laxative. And overuse can cause excessive loss of water and body electrolytes. Okay, that's why it's only used in isolated cases of constipation, or when you want to prepare the colon for radiographic and endoscopic examination. طيب, it should not, it's contraindicated if the person has nausea, vomiting, or abdominal pain, because abdominal pain might indicate that there is appendicitis. And if you take the laxative and you have appendicitis, this might promote rupturing of the appendix. Okay. طيب, for adult the dose will be 45 ml if the concentration of the oil in the emulsion is 67%. طيب, simethicone emulsion. Maybe you heard a lot about bloating or gases in the intestine and belly. Okay, and this problem is especially inconvenient when you have new babies born. Okay, in many cases they will have gases in their belly. And what can we do? We can administer simethicone emulsion, because simethicone is itself can be considered as a surfactant, and this type of surfactant is anti-foaming. Okay, anti-foaming, and it prevents the formation of foam bubbles. If we go back to the categories of surfactants and look at them, just to show you what do we mean by anti-foaming. See here, anti-foaming is between 1 to 3. What do they do? If a person takes this simethicone emulsion, what will happen? It will cause the bubbles in your belly to unite, okay, forming a bigger bubble, and this will allow the removal of these gases easily and more quickly than if they are small individual bubbles. And as I said, this can affect adults and infants as well. Okay, and of course we want to avoid this, especially for infants. Why? Because they keep crying, they keep crying and crying and crying, and they will not be able to sleep. So what you do is you give these things in order to for the gas to be relieved. Okay. طيب, other examples of topical emulsion other than oral, we discussed oral. We have many hand and body lotions in the form of oil in water emulsions. Uh, we have also طبعا again, when I say lotion, lotion is not only emulsion, it can be ايش, it can be solution or suspension even. Okay. But in addition to administering it for dry skin conditions, there are preparations for systemic absorption, such as estrazorb. And estrazorb contains estradiol, and it's used, for menopause to relieve the symptoms of hot flashes and night sweats that comes with menopause. Okay, there are other preparations such as antifungal and anti-inflammatory preparation, and even shampoo in the form of emulsions. Okay, I hope it's clear. I hope you enjoyed this lecture. If you have any question, you know how to reach me. Thank you very much and have a nice day.